This is lesson 5.6b, and the main part of this lesson is this new change of base thing, and we're going to be solving some more logarithm problems today. This first page is just a lot of the same of what we've already done. So you should be able to do here, there's a thunderstorm outside for me. You should be able to do number one, and you should be able to do number two. One, you're just evaluating in your calculator, and two, you're going to rewrite these as using the same base method, and then see if you can go ahead and solve it. We'll actually talk about C together, so you'll just do A and B for number two and go from there. Okay, so the first three, all you do is put them in your calculator. If it says a base 10 like A, that's just, that's a common log, and you can just use the log button. So just looking at our calculator here. So when I did log 5, I get 0.699, log 4, 0.602, log negative 6, you get an error because, again, you can't have the argument, which is this thing here. It cannot be a negative number, okay? For number two, I changed A and B, I changed them from, actually all three of them, I changed them to exponents using definition of logarithms. So 2 to the x equals 16 for the first one. So I rearranged things, wrote it as an exponential. I changed 16 to base 2, and I get x equals 4. Because I have the same base, I can say the exponents are equal. B, same procedure. C, I take the log and I change it to exponential. 4 to the x equals 50. But the problem here is that that is not 50 cannot be written as a base 4 easily. I mean, it would be a weird decimal number. So we're just going to give up on that one. You cannot solve this with same base method. However, today we'll learn how to solve that as a log, and you won't have to change it to same base method really anymore at all, because you'll be able to solve logarithms. Again, just reiterating definitional logarithms so that you make sure you can go back and forth between a log and an exponential log. Why? Well, for us, the main reason why is because it helps us solve things, okay? So now in this first problem here, the A is just asking you to write it with a logarithm, all right? So let's do the first one together, and then you should be able to do many of the others on your own, okay? So log base 10. So I write, if I'm changing it to a log, I usually just write the word log first. Just write log, okay? And then write the lower thing, which is the base 10. And then it's the other number. You never keep these two numbers together, the 10 and the x. So 10 to the, and then this is going to be 6. That's our argument, equals what was the exponent is like that. Now, do I have to write the base 10? No, you could write log 6 equals x, and then you've changed it to a logarithm, okay? That's something you could type in your calculator and solve. It's not asking you to solve, but you could do that pretty easily. All right, let's do a couple more here. Log, I always write the word log first, subscript 10, that's the base, and then the other number, the argument, 105 equals exponent x. Same is true with the, I'll do some across the aisle there, okay? Those, same thing. This would be for 2 to the x equals 64 log, and then you write the subscript, the base, 2, 64 equals x, like that, all right? You should be able to do the other 7 on your own. I won't make all of them. If you're doing the ed puzzle, they won't all be ed puzzles, but you should be able to do them. All right, so taking a look here, I've rewritten all of them, even the ones on the bottom. If you take a look, it just because it's a negative exponent or because it was a fraction, it doesn't really matter in terms of the process of using the definition of logarithms. So go ahead and look at those and make sure you've got all of those right, and we'll go on to the next page. All right, the next thing we're going to talk about is the change of base properties. So it says here, the same base method is very limited. Things must be set up perfectly in order for that to work. Like we did on the last, in the warm-up, right? You have to have the number be something that you can write it as the same base as the other side of the equation. And that's not always going to happen, right? So it's a limited method. And so One way we can solve things, okay, is using the definition of logarithms and this change of base method. So we know that if it's a base 10 log, we can use that button on our calculator, the base 10 button. And this little change of base property basically says that if you have any base, as long as a would have to be positive there, right? If you have any base like a, you can change it to two base 10 logs, all right? So for instance, I'll skip down here down to b, and then we'll talk a little more here. This log base 7 112, I can change it to log, and then whatever that number was. So log 112 over, and then log a. So log whatever the base is, log 7. Now these are two base 10 logs. And so if I know that on my calculator, I can type in, using my base 10 button, log 112, end parenthesis, you got to make sure you close it up, divided by log 7. Okay, you don't have to close that one up because you're done typing. And you get 2.4, let's just say 2.42. Let's round it to the hundredth. So 2.42. Actually, I rounded to the thousands, so let's just do them the same as I did in my notes key. All right, 2.425. All right. So again, if your calculator has that log button on it, and in order to solve problems using that button, and if it's a different base, it's not log 10, you can use the change of base property to change it to two base 10 logs. Thinking back long ago, before we had the technologies you have with your calculators, I think I had a calculator that had the log button in it, but we also had tables in the back of our math books or science books that had all the base 10 logs in them. So like when you type log 6 in your calculator and it tells you the number, like we had those with tables, right? And so, but they didn't have tables that were not base 10 tables. They were base 2, like base 2 tables or base 3 tables. They didn't have any of those. If you had a different log base, okay, then you would have to use this change of base property. Now, if you own, it says right here, if you own a TI-84, you probably won't need to use this change of base very often because your calculator actually can do this with a different base, and I'm going to show that to you in a second, right? If you have a TI-83, then you're going to have to always use this change of base property because it doesn't have that functionality. Where do you find this? If you go to math, all right, and then scroll over to number right here, and you go down. I'm wrong on that. Go stay on math, scroll down. I believe it's down here. You should, yep, it was just under the math. Log base. Now, if you do not see that and you have a TI-84 calculator, I can update the software in your calculator. That would be the case only if your calculator is older. If you have a newer TI-84, you'll have this in there, okay? So you see the log base thing, you hit enter, and now I can actually type this in, right, like that, and I can get 2.4, the same answer, right? So I didn't have to use the change of base property. Now, honestly, using the change of base property doesn't take very much time to just rewrite it that way. You'll need to know how to do that on the test. However, again, it's just because it's possible. Let's say you were asked to do something without a calculator and you had a base 10 table, you could do it that way. But chances are, if you've got your TI-84, you're probably good to go. All right, so we'll do one more together, and then you can do C on your own. All right, so I'm going to change this for letter B here. Log, I'm using change of base, log, and then I write this number on top. Log 316, that was the argument, over, and then log, and the base, which is 5. Type this into my calculator. Log 316 end parenthesis divided by log 5. 3.576, let's say. All right. Then you go ahead and do C. You should have gotten 2.465. All right, now we're going to solve these equations using definition of logarithms and change of base. This is where logs become pretty powerful, right? Because looking at number one here, um, prior to today, we would have had to use the same base method to solve this. We'd have to say, okay, how can I write 40 as a base 6? And you can't. 6 squared is 36. 6 to the third is 216. It's just a little bit bigger than 6 squared, right? Because 36 is just 40 is just a little bigger than 36. So it's probably 2 point something, but I can't quite do it. So what we're going to do instead is use definition of logarithms to change this to a log. So I'm going to write the word log. That's how I start when I change something to a log. Then write the base, 6. And then the 40 is the argument. And by the way, I think that 6 that I wrote is awfully big. It should look like a subscript. Yours should too. Otherwise, you can kind of get that confuse yourself as you're writing. So log base 640. Log and 40 are like on the same line, same size, whatever. Now I can go here and I can type in, well, I can use change of base, right? And I'll go back here. So I can now change. So this log, this equals x, by the way. Didn't even finish that. Now I can change this to change of base, log 40 divided by log 6, and I can type that in my calculator. Log, not that one, log 40 divided by log 6, and I get 2.059. Okay, that was just a little bit bigger than 2. Remember, we said it was a little bit bigger. 40 is just a little bit bigger than 36. So 2.059. Now, that's what x is. You can, and if you have a TI-84, you might as well, instead of using this change of base every time, go to math and go down to the log base, which I think is the same as going up to, if you want to do it that way. And then you can actually just type this in, 6 down here and a 40 here, okay, like that. Same answer. You go ahead and do 2 and 3. All right, let's take a look at our answers there for both those. You should have x equals 1.585 for the first one and x equals 2.134 for the next one. Again, if you have questions about that work, make sure you ask, right, so you know that you're feeling good about this. Last one is talking about inverses. Okay, so find an inverse of the function. So now you're starting with an equation, you're going to end with an equation, all right? But you're going to use a definition of logarithm to do this, all right? So we know with inverses, the inverse is just the flip of x and y. We learned that in the last section. So x equals 12 to the y, right? That's just switching x and y. That's what an inverse is. But we don't usually write equations where it's like x equals something. It's usually y equals blah, 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 within it has an x in it. That's how we like to write equations. So we're going to take this exponential equation and we're going to change it to a logarithm so that we can get y in a better place. Okay, so when I change something to a logarithm, I use the word log first, and then I write the base, which is the lower thing, 12. It's a subscript here. And then x equals the exponent, y. Okay, so I'm going to write the y first because that's kind of cooler, you know? So that would be your inverse equation for an exponential equation. Likewise, we could start with a log equation and change it to an exponent. So here I have this log equation. If I want to know what the inverse is, I will switch x and y. So x is being a little delayed equals, and then we have log base 3y. Now y is not where I want it to be. I'll change it to an exponential to see if x is in a better spot. So I start with a low thing, 3, come on, pen, 3 to the x equals, and then I'll have y. Now y is by itself, so I might rewrite it with y first. Y to the y 3 to the x. Remember, both logs and exponentials are functions, so these are both sets of functions. Now this last one, 3, is kind of crazy fun, okay? If you start with something like this and it says, okay, why this is a crazy one is x is the base and it is, I've never had x down there. Usually we always have a number down there, so that's why it's kind of fun. I need to write this as an inverse, so I'm gonna switch my x and y. X, come on, pen. It's real slow to get started, and then once I start writing, it's okay. Oop. Got too close to the edge. So I have this log, and that's supposed to be a little base y 5, base y, and then 5 as the index. All right, I don't like where y is, so I'm going to change it to an exponential. So I start with the base, which is y here, y to the, and then it's x equals 5. Okay. And we've not had something like that before either. I just want y equals. I don't want y to the x. So how could you get rid of this exponent x? All right. We were doing this in the last section. If you don't want to have, like when you had, oh, b to the third equals 5. Remember how we raised both sides to the 1/3 like that, right? You can do this here too. I don't want that x there, so I'm going to raise the left side here to the 1/x. But then I have to do that with this side too. Now this is a pretty funky looking equation. It's written as an exponential, but because that's a fractional exponent, it would look really weird. It wouldn't necessarily look like growth or decay. But now I have an exponential-like equation, all right, where I have it in terms of y equals. All right, so that's the end of this lesson.